Given f of x equal to square root of x minus 8, when x is greater or equal to 8, you want to find inverse of f of x. Step number 1 to find the inverse is to replace the position of x and y. Here we have f of x or y is equal to square root of x minus 8. Everywhere I see y, I'm going to replace that with x. Everywhere I see x, I'm going to replace it with y. So step number 1 is to exchange the position of x and y. And step number 2 is to solve for y. And that would be your inverse function. To solve for y, here I can square both sides. To eliminate the radical on the right hand side, I get y minus 8 is equal to x to the power of 2. To solve for y, I would add 8 to both sides of the equation. So this would be my inverse function. I can write it as its symbol. Y inverse is equal to x squared plus 8. Or I can write it as inverse of function x is equal to x squared plus 8. Given f of x equal to square root of x minus 8, where x is greater or equal to 8, we want to show that the composition of f respect to its inverse of x is equal to x. We found the inverse of x previously as x to the power of 2 or x squared plus 8. So composition of f respect to its inverse of x is equal to f of inverse of x. I know what inverse of f of x is x squared plus 8. So we want to find f of x squared plus 8. We go back to our f function, and everywhere we see x, we're going to substitute x squared plus 8 to find f of x squared plus 8. So there's only one place here I need to substitute x for x squared plus 8. And as you can see, you would get square root of x squared, which is equal to x as we expected, since these two functions are inverse of each other. We can also find composition of inverse respect to f, and if you do this, you should also get is equal to x. So you can try this on your own and verify that. Find the domain, all intercepts, all asymptotes for this function. If I factor x squared minus x minus 2 at the top of the function, y is equal to x minus 2 times x plus 2. And at the bottom of the fraction, we have x minus 2. You notice that x minus 2 and x minus 2 would be equal to 1, assuming that x minus 2 cannot be equal to 0. So x cannot be equal to 2. So our function f of x or y is equal to x plus 1. This is the straight line. If I let x be equal to 0, y will be equal to 1. So my graph going to passes through this point here. And if I let x be equal to negative 1, y will be equal to 0. My graph also going to pass it through point negative 1. So this would be the straight line, except x cannot be equal to 2. So if I go then graph this line here, at x is equal to 2, there would be a hole on my line. So if this is 2, you're going to put a little hole here to show that this is where your graph going to be discontinued. And this is how you graph this one. And there is no horizontal, vertical, or oblique asymptotes for this graph.